So we are dealing with the 8th problem in the NSEP 2025 series, and it is one of a very wonderful problem which came this year. It is based on the idea of simple harmonic motion, and the problem is stating a pendulum consists of a heavy but very small bob of mass capital M suspended at the end of a rigid rod of mass M and length L. So it must be noted over here that the length of the rod is also considered and mass of the rod is also considered. So at the end of a rigid rod, and the bob is of mass capital M. The period of small oscillation in the vertical plane about the horizontal axis through the upper end of the rod is. And now we are asked to calculate the time period of oscillation. So let us start approaching the problem. Before that, let us draw a diagram of our own to have the understanding of the problem. So this is the diagrammatic situation of the problem which we are going to discuss. So we have a rod of mass small m, length capital L, and a heavy bob of mass capital M at one end. So if we give it a oscillation by an angle theta, so over here in the diagram I have drawn theta to be considerably large, but theta is very small, as we have stated in the problem already that we are giving small oscillations. So for small oscillations over here, so theta being very small, we will try to solve it that way. So over here we have stated that the mass of the rod or the weight of the rod is at the center of mass point mg, which is at a distance L by 2 from fixed end, and hence this distance will become L by 2 sine theta. Similarly, the total length of the rod is L, at the end of which a capital mg mass or the heavy bob is suspended. So over here we can say that the total length from the suspension point to the point where the weight is acting is L sine theta. So these distances will be useful in writing the torque equation about the point of suspension. So we have a point P as the torque as the point of suspension, and these distances L by 2 sine theta and L sine theta will be helpful in writing the torque equation about point P. So for writing torque equation, I will need one more aspect, that is moment of inertia. So for moment of inertia of this system, we are saying that for the rod suspended at one end, moment of inertia is ml square by 3, and for a mass m at a distance L, it is ml square. So this is the value of moment of inertia of this particular system. And now if we write the restoring torque about point P, so we can say that it is equal to mg L by 2 sine theta plus capital mg L sine theta. And over here we are taking theta to be very small. So for a small oscillation, that is theta is very small, so sine theta can be roughly written as theta. And if we write tau as I alpha, so if we are substituting I alpha over here, so we can say that the torque can be written as I alpha, that is ml square by 3 plus capital ml square alpha, and this is equal to minus of mgl by 2 plus capital mgl, and then theta over here. So we can clearly see that we are trying to get the form alpha equals minus omega square theta. So to get it in the form alpha equal to minus omega square theta, let's do one more round of calculations. Over here we can chop out all the L. So we are left with small m plus 3 capital M by 3 into L and alpha, which is equal to minus of small m plus 2 capital M by 2 into G times theta, and hence over here we can say that alpha is equal to small m thrice of small m plus 6 times of capital M upon twice of small m plus 6 times of capital M and then we write it as G by L, and then we write it as theta, so under root and then square. So we write it this way to get the form omega square theta. And over here, if we take 2 common, then we can write it as m plus 3m, and alpha equal to minus omega square theta, and then t equal to 2 pi by omega, where this is the entire value of omega which we have. So if we write it together, we can write it as that if we take 3 common from here, we will be left with m plus 2 capital M. So divided by omega, so m plus twice of capital M upon 2 taken common, m plus thrice of capital M. So over here we can say that we have taken 3 common, so 3g by 2l, and this entire term is in square root. So over here we can write it in the final form which is given in the problem, m plus 3m divided by m plus 2m, and then we have 2l by 3g. So this is the format in which the answer is given to us in the problem which we are trying to solve. So this is the time period equation. So if we go to the options which is given to us, so second alternative is matching with what we have calculated. So for this particular problem, alternative 2 is correct. So it is based on the very simple idea how to write SHM equation in the terms of alpha equals minus omega square theta. ये आइडिया पे पूरा क्वेश्चन बेस्ड है, और इसको लिखने के लिए हम लोगों ने पहले टॉर्क लिखा है अबाउट पॉइंट ऑफ सस्पेंशन, और फिर आई अल्फा कर दिया गया है, वेर आई इज रिटन फॉर बोथ द रॉड एंड मास अबाउट द पॉइंट पी, and then we have done the sort of calculation which is needed to get the answer in the fashion which they want us to write. So that's the problem which we have discussed.